eye. And it's like, you look at it, it's like, that is so foreign. I don't even know what that is. Well, once you turn it this way, you'll be able to see that, okay, that's an eye. Now, when you look at the eye, basically all you see of it is about that much. So like in humans, our eyeballs are really only about an inch in diameter, but when you look at somebody, you're only seeing about a sixth of it. The rest of it is buried in your bony orbit. And back behind that bone, back behind your eye socket, is all this stuff. It's just surrounded by lots and lots of fat, which cushions and protects it. That's what all this yellow stuff is. Lots of fat helps to cushion and protect it so it doesn't get harmed. And you also see all this brown stuff. This brown stuff is muscle. All these muscles that move your eye externally. There's more rings of muscle in there. So helps your eyeball move in all those different directions. Now, another thing you're going to see on the back side of the eye is this. It's like a long stalk. It kind of almost looks like a button. That is the optic nerve. The optic nerve comes out of the eyeball and plugs into the brain. So it's kind of long. It depends on how big the animal is. But there's the optic nerve, and what it would do would be to plug into the brain right there, because that's where the optic nerves are. Of course, it would be longer, but that's how it goes. All right, so what I'm going to do first here is I'm going to cut some of this crap off, okay? Oh, also on the front here, this is the cornea. And it's real cloudy because it's dead. And in life, it's clear. We can see through it. But I'm going to squeeze it just a little bit so it plumps up. That's the cornea. This thing's full of fluid, all right? When we cut it open, you're going to see, first you're going to see a real watery substance run out. That's called the aqueous humor. Aqueous humor fills the front part of the eye. It fills the part of the eye in front of the lens. Vitreous humor, which is a thicker substance, fills the posterior chamber. Vitreous humor is a thicker kind of gelatinous goo. So what I'm going to do is just take my scissors. I'm going to cut these muscles off because it makes it easier to cut into the eye if we get rid of this stuff first. So I'm just trimming this eyeball up. Just all that's muscle. The brown stuff's muscle. The yellow stuff's fat. So I'm just kind of trimming close to the eyeball so I can get rid of that stuff. It just makes it a little bit easier to get into the eye if I get all that fat and fiber off of there first. So I'm just going to put that all to the side. And then what I'll do is just position my eye like this. And then I'm going to cut it basically in half. And you can see I've already cut one. I just put my scalpel about right there and then just cut it. You can cut it all the way in half so it's in two pieces, or almost all the way in half. It's up to you. So I've got it sitting here. Now you're going to be careful here because this is hard to get through. Remember that you got three coverings at the outside of the eye. The white of your eye, which is called the sclera, and then there's, well, first we got all this fat and muscle to get through. Then we cut through the white of the eye, which is the sclera. Then we have a deeper layer that's called the choroid. And then we have the inner layer, which is called the retina. So we got to go through all these layers, and it's a little difficult to get through. So I'm just going to take my scalpel, and I'm going to give it a poke here. Be careful. You don't want to cut your thumb off at this point because you need that later. So once I get it poked through, see how the scalpel is in there? I'm just going to start sawing at this. Now see all that watery crap that's running out? That's that aqueous humor. The aqueous humor is what nourishes the front part of the eye because some of these structures, the cornea, the lens, are avascular, and it has to get their nourishment from somewhere. It gets it from that aqueous humor. So I'm just sawing it, and what's going to happen is we're going to cut it, and we've got anterior part of the eye, posterior part of the eye. So I had some fluid that ran out. That's that aqueous humor, constantly replenished. I'm going to cut this a little bit more just so you can see a little bit better. Okay, so I've got anterior chamber of the eye. How can I tell that? Because that's where the cornea is. Posterior chamber of the eye. How can I tell that? That's where the optic nerve is. And then see this crap that just fell out? That snotty looking stuff? That's the vitreous humor. Vitreous humor is like a thick, snotty, gelatinous goo that fills the whole posterior chamber of the eye. So I'm just kind of scooping that out now. That's that gross, snotty stuff. Okay, so once I do that, we'll see what's going on in the anterior chamber. We see this, there's a ball in there. So I'm just gonna lift that ball out. Cool. That ball is the lens, all right? And some of the schmutz came out with it. I'm just gonna peel that off. This is the lens. It is an avascular structure. Avascular meaning it has no blood supply. It's round. It's made up of crystalline proteins. It's kind of like an onion. So when you'd start to take your scalpel and peel it, you see layer upon layer upon layer upon layer. This thing's kind of cool. It sits in here like that, and there's a circular muscle around it. And what this does is it changes shape. So if I'm looking across the room and I'm reading that sign up there, hazard identification system, my lens is long and skinny. Then if I focus on the printed page close up here, so I change my point of vision from far away to close up, my lens changes shape. It goes from being long and skinny to short and fat, thicker and shorter. That's called accommodation. The lens is accommodating to adjust your vision from far vision to near vision. You guys have no problem doing that. You can look up, read something far away, look down at your paper, okay, I see that, and look up. Your lens accommodates immediately. As you start getting into your 40s, what you'll notice is you look up, okay, I can read that just fine. You look down, it's like, whoa, I can't, what is that? And you have to take the paper and start kind of playing trombone here. Why? Because your lens isn't accommodating the way it used to, so you have to accommodate for it. And the reason why is because the elastin, the collagen that your body supplies, starts to diminish in your 40s. So it's not going to change shape as readily as it once did, and you are going to go into bifocals. All right, so that's your lens. I'm just going to pop that out. Now we see an obvious hole in the center of this eye. That hole is the pupil. The pupil is when you look at somebody, that black spot right in the center, that's the pupil. And that ring around it is going to change shape depending on what light you're in. Now this isn't, of course, going to change shape because it's dead. But if we're in dim light, our pupil's going to dilate. And if we turn on a bright light, it's going to go down to a little pinpoint to disallow light from going into the back of the eye. So when we're in dim light, the hole gets bigger, and in bright light, it gets smaller. Surrounding the pupil is this striated portion. Striation means striped. All the way around it is this striped area. And on the cow, it's black. This is the iris of the eye. And the iris is the colored part of our eye. So some of us have brown irises, and some of us have blue irises, and some of us have green irises. Cows all have black irises. So they all have black eyes. And we have all kinds of different colored eyes. So the iris is the colored portion. Now as we move to the posterior side of the eye, what we see is, first we see this yellow film here, okay? That yellow film is called the retina. It's the innermost lining of the posterior chamber of the eye. And it's very, very thin. When I pull this off, I'm not going to be able to put it back. When I pull it off, it's going to just tear and shred. But I want to show you what's underneath it. So I'm holding that yellow structure up, that's the retina, and I'm going to pull it back. And as I pull it back, see how easily it tears? It's tearing. Now I'm going to try and put it back on there. That's not going to work. It's just too delicate. It just won't. So there's the retina. What's underneath is what's called the choroid. This real pretty blue, like abalone colored, it's like seashell type stuff. This is called the choroid layer. It's pretty thin. Listen to it. As I pull it up, you hear that tearing sound? It's blood vessels. Okay, so that's the choroid, that blue stuff. So the innermost lining of the posterior chamber was that retina. Then we see the choroid layer. Deep to that is what's called the sclera. And I told you that the sclera is the white of the eye, and you're going to get confused because you're like, well, that looks black. Well, that black is just the back side of the choroid. So if you just take your paper towel, you can wipe that black stuff off, and you can see that it actually is white. This whole thing, all this is sclera. As I pull the fat off and the muscle, what I'm pinching now is sclera. The white of the eye covers your entire eye all the way around up to the cornea. So here's sclera as well on the front. That thin layer right there. So let's do this again. I'm going to just switch to the side because I've still got the retina intact over here. Put the lens back in. All right, so outside of the eye, we see the cornea. On the other side, the posterior side, we see the optic nerve, okay? That's what innervates the eye so you can see. I cut the eye open, and what we see, first thing we'll notice is the lens. There's the lens, that little bouncy ball there. Then we see the hole in the center of the eye. That's the pupil. The striped black stuff all the way around, that's the iris. On the posterior side of the eye, we see the retina here. It's still intact for the most part over here. And as I pull it up, it's not going back on. There's the retina. And that real pretty blue stuff is underneath. That real pretty blue layer is the choroid here. So I'm lifting the choroid up now. And then here is the sclera, what I'm pinching. This, it looks pretty thin, but it's kind of tough and fibrous. That's the sclera. So those are the parts and pieces of the eye that you need to know, okay?
How would you label those for the test?
I would make it very, very clear and